Hello everyone. So let's now solve question number 8 and 9. So the data for the question 8 and 9 is same as that we seen for practice assignment week 3 question number 7 and 8. Right. Suppose in a village there are 4 farmers A, B, C and D, each owning 1 acre of land. They cultivate paddy, pulses or sugarcane in their land as follows. Farmer A uses 50% of his land for paddy, 30% for pulses and the remaining for sugarcane. Farmer A uses 50% for paddy, 30 for pulses, and the remaining that is 20% for sugarcane. Then farmer B uses 40% of her land for paddy and she divides her remaining land equally for the pulses and sugarcane. So 40% for paddy and 30% for pulses and sugarcane. Farmer C uses the whole land for paddy only and farmer D uses 30% for paddy, 30% for pulses and the remaining for sugarcane. So 100% for paddy and 0% for pulses and sugarcane. And for farmer D, 30% for paddy, 30% for pulses, and the remaining that is 40% for sugarcane. So it's the same data that we use for practice assignment week 3, question 7 and 8. Using the above information, answer the following question. Suppose the area used by farmer for different crops is denoted by row vector. So we have 4 row vector A, B, C, and D. So this is our first row vector, second row vector, third row vector, fourth row vector. Let S be the span of the resulting 4 row vector. Choose the correct set of options. Option 1. The row vector corresponding to the area used for different crops by farmer D can be obtained as a linear combination of the row vector corresponding to the area used for different crops by farmer A, B, and C. So that means we can write this vector as some linear combination of these 3 vectors A, B, C. So let's check. So D option 1 is telling that D is some linear combination of alpha A plus beta B plus gamma C. So one way to check that is our D vector is 3 by 10, 3 by 10, 4 by 10 is equal to some alpha times 5 by 10, 3 by 10, 2 by 10 plus beta times 4 by 10, 3 by 10, 3 by 10 and plus gamma times 10 by 10, 0, 0. So this uh, this is our a system of linear equation. If we try solving the system of linear equation, we will get 3 by 10, 3 by 10, 4 by 10 is equal to minus 1 times 5 by 10, 3 by 10, 2 by 10. So that means when we are trying to solve the system of linear equation that we have seen how we can solve them in week 2. So we will get the value of alpha to be minus 1, value of beta to be 2 and gamma to be 0. So yes, we can write vector D as some linear combination of the vector A, B and C. So that's why option 1 is correct. Option 2, the row vector corresponding to the area used for different crops by farmer D can be obtained as a linear combination of the row vector corresponding to the area used for different crops by farmer A and B. So just as how we done in option 1, as we obtain the result that D is equal to minus 1A plus 2B plus 0C. So that means it is also D equal to minus 1A plus 2B. So that's what option 2 it is telling that the row vector for farmer D can be written as a linear combination of the row vector by farmer A and B. So that's why option 2 is also correct. Option 3, the row vector corresponding to the area used for different crop by farmer C can be obtained as a linear combination of the row vector corresponding to the area used for different crops by farmer A and B. Now here, option 3, we need to check whether C, vector C, is a linear combination of A and B or not. So that's what we need to check. But notice that now we have three vectors in R3. So we can use our matrix method that we can put these vectors column wise and form a matrix and check the determinant of this matrix. If the determinant comes out to be non-zero, that means the vectors are linearly independent. So we cannot form the linear combination of them one another. But if the determinant comes out to be zero and the vectors are linearly dependent, then in that case we can write C as a linear combination of A and B. So let's try checking that. And 3 by 10, 10 by 10, 0 by 10. 0. Now for simplicity, I will be doing some row operation that we will take common 1 by 10 from each row. So what we will get is 1 by 1000 times. So the determinant of this matrix is equal to the determinant of this matrix times 1 by 1000. So now I will be finding the determinant of this matrix along this column expansion. So that would be 10 times. So as the determinant comes out to be non-zero, so that means these vectors A, B, C are linearly independent. So we cannot write C as a linear combination of A and B. So option 3 is wrong. We could have also done the case like we did in the option 1, that is finding the uh, that putting them in system of linear equation type and solve them. But this method was easy, that's why we done that. The row vector corresponding to the area used for different crops by farmer D can be obtained as a linear combination of the row vector corresponding to the area used for different crops by farmer A and B, A and C. So similarly as we done in option 3, so now we need to check whether D is a linear combination of A and C or not. So again we will form the matrix with vector A, C and D and check its determinant. If it's non-zero, that means the vector are linearly independent, so they cannot form linear combination of one another. If it is zero, then in that case. So so again, just how to simplify in option 3. I will take 1 by 10 common from each row. So I will be finding the determinant along this column expansion. So again, the determinant is non-zero. That means these vectors are linearly independent. So D cannot form a linear combination of A and C. So option 4 is also wrong. Now let's solve question number 9. Let S be a vector space defined in the previous question with usual addition and scalar multiplication on R3. Which of the following set will not be a basis for S? So S in the previous question was defined as the spanning set for all the 4 row vector. So this was our A, this was our B, this was our C, and this is D. For simplicity, I have removed the 1 by 10 from these vectors. It doesn't matter to our solution. It's just a scaling by 1 by 10. So now we have to check which of the following cannot be a basis. So in the previous question, we got one result that the vector A, B, and C are linearly independent. So that was for option 3. Here, we got the determinant of the matrix formed by the column vector A, B, and C to be non-zero. So that means vector A, B, C are linearly independent. And we also got one result that we can write with the vector D as a linear combination of vector A, B, and C. So that's what our option 1 was. We can write D as some linear combination of the vector A, B, and C, that is -1 times A, 2 times B, plus 0 times C. So from this, we get that dimension of S would be 3, and S can be spanned by vector 5, 3, 2, 4, 3, 3, and 0, 0. So this can serve as a basis for S. We should take basis for S. Okay. So that's what there in the option 3. So clearly option 3 is the wrong answer. Now option 1 and 2, as they contain only in option 1 there's only one vector, and in option 2 there's only two vector. So we can directly say that there are wrong options, as the dimension of S is 3. So for the basis, they at least they must contain only 3 vectors, not more, not less. And option 5 is also wrong, as there are 4 vectors in R3. So clearly they can never be linearly independent set, and basis has to be linearly independent set. So option 5 is also wrong. Now option 4, if we see that this is our vector A, this is our vector B, and this is our vector D. In option 2 of the previous question number 8, we got this result also that D is a linear combination of A and B. So this means this set is not a linearly independent set. So this can also does not serve as a basis. So option 4 is wrong. Also one more point, as the dimension of S is 3 and it has the vector in R3. So that means the spanning set for S is R3. Thank you.